Welcome to another video by AskMath.com. Let's read the directions to the problem. For each ordered pair, identify whether or not it is in the solution set for the system of inequalities. Given x plus 3y is greater than or equal to -2, and 3x minus y is less than 4. And then the ordered pairs that we're given are 1, 2, 2, -7, and 1, -1. So a system of inequalities just means that you have two or more inequalities. We have two here. And they're inequalities because they don't have equal signs, they have inequality symbols, so greater than or equal to symbol, or a less than symbol. And when we're asked to identify if the ordered pair is in the solution set, that just means take these ordered pairs, which are an x, y value, coordinates on a graph that would make a point, and substitute the x value, the 1, in for the x, and the y value, the 2, in for the y, and see if the left side then, once you do that, is in fact greater than or equal to -2, and then do the same for the other inequality. If an ordered pair works for both inequalities, so that the inequality symbols are true, the left side is greater than or equal to -2, or the left side is less than 4, then that ordered pair, if it works for both inequalities, is in the solution set. It is a solution. So what we really are doing is three different problems. We're going to see if this ordered pair is in both, works in both inequalities, the second ordered pair works in both, and the third ordered pair works in both. So let's organize ourselves, and just at the top we're just going to remind ourselves of the ordered pairs that we're going to test. And then we're going to test them in each inequality. So in the first one, x plus 3y greater than or equal to -2, I'm going to write parentheses where the x was, because I'm going to substitute, and same with the y, I'm going to substitute the values in there. And then for the other inequality, I'm going to do the same thing. 3 times parentheses where the x was minus parentheses where the y was is less than 4. You might be able to do some of these in your head, but when you get minus signs here in the original problem, as well as negative symbols in your ordered pair, it can get a little confusing with a bunch of negatives. You're more likely to make a mistake in that case, so it's a good idea to use parentheses where the variable is and just go ahead and write this out. It doesn't take very long. Okay, so I'm going to take the x value, which is the 1, and the y value, which is the 2. I'm going to substitute them in where x and y were. And now I'm going to use Pemdas. Remember, when you evaluate, you use Pemdas, the order of operations, forward. You could also call this simplify. And there's nothing inside the parentheses happening. There's no exponents, but there is multiply. 3 times 2 is 6. Then, continuing down, I do the addition. Plus 1 is 7. Is 7 greater than or equal to -2? Yes. So we're going to draw a smiley face. Yes, it is. Next one. Replace what the x was with the 1 and the y with the 2. And now use Pemdas. Again, we multiply first. 3 times 1 is 3. Minus 2 is 1. Is 1 less than 4? Yes, it is. And so the answer, because we have two smiley faces, the answer for this ordered pair 1, 2 is yes, it is. Same thing for this. And so again, I'm going to use parentheses where the variables were in each inequality. Oops. And as long as I'm doing it, I'm just going to set up the last problem. The setup looks the same for each point. Okay, so the point that I'm plugging in this time, substituting, is 2 for x and -7 for y. I'm just going to go ahead and do it for both right away here. And then I might as well set up my last problem as well. And then my only job is to go through and do the evaluation, simplify each one. Okay, so remember that we multiply before we do the addition. So we've got a positive 3 times a -7. Positive times negative makes negative. 3 times 7 makes 21. That's a -21. Now we put the 2 there. We say 2 minus 21 is -19. And nothing changed on the right side. And so now, is negative 19 greater than or equal to negative 2? No, it's not. Frowny face. And at this point, you don't have to try the second one. You could if you want the practice. However, because the ordered pair didn't work in one of the inequalities, it is not a solution to the system of inequalities, because the system means it has to work for both. So it is not in the solution set. So we can already say the answer to this problem is nope. And last one, 3 times negative 1 is negative 3. 1 minus 3. 1 minus 3 is negative 2. Is negative 2 greater than or equal to negative 2? Yes, they're equal. Okay, on this side, don't forget that this minus is a negative 1, and we still do multiplication first, and so we actually have two multiplication problems here. We've got 3 times 1 and negative 1 times negative 1, so you can do either multiplication first, so 3 times 1 is 3, negative 1 times negative 1, two negatives multiplied make a positive, 1 times 1 is 1, is 3 plus 1, which is 4, less than 4? No, it's not. It is equal to 4, but we don't have that extra equal sign under the inequality symbol, so this says is 4 less than 4? 4 is not less than 4. And so the answer to this one is no. So, yes, no, no. All right, those are the answers to this problem. Thanks for watching another video by AskMath.com. Don't forget to go to www.askmath.com and check out the rest of the videos.